Okay, this is part 2 of our Chapter 3 practice test. We're now on problem number 5. Usually a student's first response with word problems is to panic. Don't do that. All right, this is just using skills that we've done before. All that we're going to do is we need to take a closer look at the setup. I've got a rectangle. All right, this rectangle has got an area and it's got a width. I need to find its length. Okay, well, just think back a little bit. Just relax and say, well, what is the area of a rectangle? The area of a rectangle is length times width. They give me the area of a rectangle is a polynomial, and they give me the width. So if I take the area and divide it by the width, what am I going to get? I'm going to get the length. So really what they are trying to tell me to do is take this polynomial here and divide it by this polynomial. All right, you might say, well, why didn't they just tell me that in the first place? Well, we got to think a little bit. Okay, now that you've got the problem, you know it's just polynomial long division. Get your setup, use your placeholders as you wish, do your long division, and get your answer. And this will be your answer right here. It divides in evenly, no remainder. Okay, so that is your function for your length, and that is the correct answer for number 5. I'm not going to go into details of long divisions. That's a skill that we need to know. Again, there's a previous video to help you out on that. Problem number 6. What are they asking us to do? All right, well, we have a polynomial function, and we have a known 0. So what do we do on this? Well, what they're doing is when they tell me a known 0, they are giving me a factor of that polynomial. They're telling me that x minus 3 is a factor. So what I'm going to do is I'm going to take my polynomial and I'm going to divide it by x minus 3. You can use long division if you want, but this is a perfect example for using synthetic division. And as we see, it is indeed a factor because I have a 0 of a remainder. So if I take my original polynomial, divide it by x minus 3, I get this quadratic right here. So my original polynomial, this is a factor, this is a factor, this factor is a second order. Now it just so happens that this thing turns out to factor fairly nicely. I prefer the electric slide for factoring my trinomials or factoring my quadratics when I have a number in front of it. Some people use the tortoiseshell method, some people use the box method, some people call anti-foil, all sorts of different methods that you've learned in Algebra 2. But this does indeed factor nice into here. So our original polynomial then will factor into these 3 parts. Okay, each one of these parts I set equal to 0, and these are my values of x that will make this 0. 1 is the one that I'm given. I was told positive 3 would make this 0. I plug that in there. Yes, it will. What will make this piece 0? A positive 2/3. What will make this factor 0? A positive 5. There are all my zeros, or all of my solutions for problem number 6. Problem number 7, synthetic division, straight up. Okay, there's my synthetic division and my setup. I like to put these little guys up here just to help me keep things straight. I do the synthetic division. I do get a remainder. Okay, my coefficients down here are always going to be 1 degree less than what I started with. We started with a 4th order dividend. So our quotient is going to be 3rd order, always 1 order less. And this is the coefficients of my dividend. And I can see I have a remainder of -1. this is how I correctly report the answer for problem number 7. Problem number 8. Pay attention. This is something a little bit different. It is essentially the same as problem number 6, except one of the zeros they give me is an imaginary number. Now we know that imaginary numbers, if they are a factor, they will always exist in conjugate pairs. So actually, when they gave me one root, they really gave me 2. This is going to be a factor, and this is going to be a factor. So I already have 2 of my 4 solutions. So I took these 2 factors and I FOILed them together, and I got this little binomial right here, this little quadratic term right here. And what did I do that for? I did that. I know this is a factor. It's just kind of like saying 2 times 2 times 3 is equal to 12. Well, I can combine these 2 factors, which is what I've done here, and I can just say 4 times 3 is equal to 12. All right, so that's why I've got this in this form, because what I want to do is I want to take this, and that is going to be my divisor. That is a factor. It's a little bit larger factor, but a factor nonetheless, and I'm going to divide it into my original given polynomial. I've got my placeholder in my dividend. A lot of people like to put placeholders in their divisor. That's fine. I don't have any problem with it. However you want to do your long division, this is not a candidate for synthetic division because of this exponent. Okay, divides in evenly, not a surprise since it is a factor. So this is my quotient. So what does this tell me? Well, what it tells me is there's my 2 imaginary roots. There's what I have left over, and I say I can factor this. I can factor this as difference of squares, x minus 4, x plus 4. So what does that tell me? It tells me that I now have all 4 of my solutions. My 2 imaginaries, positive 4, negative 4, all 4 solutions for a 4th order equation.